Okay, today to study about the steroid biosynthesis process. What is the importance of steroid in the human body? Before to study how the steroidal hormone is biosynthesized in the human beings. This is a very important point. First of all, what is the meaning of the steroid? Here, according to the chemistry, here in the nucleus of the steroid, it contains four basic aromatic ring will be present. Here this ring is known as the A ring, this is known as the B ring, this is known as the C, and this is known as the D ring. Here ring A, B and C is a phenanthrene derivative, and ring D is this is the D ring. This D ring is a 5-member aromatic ring. This phenanthrene ring is combined with the 5-member cyclopentane ring, and this all the molecule is known as a cyclopentane or phenanthrene moiety. Here, how the biosynthesis process of the steroid take place in the human. First of all, when the in stress and emotional condition produced in the human by naturally or artificially, at that time the gray matter of brain in the humans, it contains the hypothalamus center. At the stress and emotional condition, what happened at that time, this hypothalamus center which release the CRF factor, that is known as the cortico releasing factor. This cortico releasing factor is responsible for to release the CRH, that is known as the cortico releasing hormone, and this cortico releasing hormone is responsible for to release the ACTH from the pituitary gland of portion of the anterior portion of the pituitary glands. Here pituitary gland having the two portions, that is the anterior portion and the posterior portion of the pituitary glands. When the CRH will be released from the hypothalamus center of gray matter of the brain, in which condition? In stress and emotional condition. At that time the CRH will be released from the hypothalamus center, and this CRH is responsible for the activation or stimulation of the anterior portion of pituitary gland. And when the pituitary gland of the anterior portion which release the ACTH, that is known as the adrenocorticotropin hormones. When this hormone will be released from this site of the anterior portion of pituitary gland, then after this ACTH will be migrated from the anterior portion of pituitary gland to the adrenal gland, and this adrenal gland is a present or located above portion of the kidney, that is the right side of the kidney and left side of the kidney. Okay, before the stimulation of ACTH, what happen? When the dietary food will be taken by the human, at that time this dietary food which undergo these some metabolic reactions and then to produce the cholesterol. Most of the person told the cholesterol is very dangerous for the human, but no, this sentence will be wrong, because some amount of the cholesterol is very essential for the synthesis of the steroid, because the cholesterol is the starting point for the synthesis of the steroid. Okay, when the food which undergo the when the dietary food will be taken by the human, what happen at that time which undergoes some metabolic reactions and to produce the ester cholesterol. Also some special cell in the human body which undergo de novo synthesis reaction. This de novo synthesis reaction, when the produce in the some special cells, also produce the cholesterol in the human body. And when this cholesterol will be synthesized from the dietary foods or some special cell, then after this cholesterol they are migrated into the blood, and they are available in the form of LDL particle, that is known as, what is the LDL? LDL means the low density lipoprotein particles. Then after when this LDL particle they are enter into the adrenal sites, first of all, what is the anatomy and physiology of the adrenal gland? Okay, so here this is the anatomy of the adrenal glands. Here adrenal glands, they are having two types. First of all, it contains the adrenal medulla parts. This portion is adrenal medulla parts, and these are the adrenal cortex sites. Here, adrenal cortex, these are the very important, and they are responsible for the synthesis of the aldosterone and the hydrocortisone and some amount of the sex steroid hormones. First of all, this adrenal cortex, they are classified into three parts. That is, they are divided into three zones. That is, first zone, this zone, it is the outermost part of this zone, and this outermost part of the adrenal cortex zone is known as the zona glomerulosa. What is the importance of the zona glomerulosa? So here, zona glomerulosa part is responsible for the secretion or release of the aldosterone hormone. What is the importance of this aldosterone hormone? This aldosterone hormone is a very important role to sodium retention and sodium retention activity, as well as they are maintain the level of the proton in the body fluid. This is the importance of the aldosterone, and then also they are very important role expulsion of the potassium in the human body. That means they are maintaining the level of the sodium as well as potassium and proton. These all the mechanism will be studied later here. Then next part is the zona fasciculata. What is the importance of zona fasciculata? Their important role is production of the glucocorticosteroid hormones as well as less amount of the adrenal androgens. Here, what is the role of the glucocorticosteroid hormone? The glucocorticosteroid hormone, their important role to produce the anti-inflammatory protein agents. This is the main important role of the glucocorticosteroid hormone, as well as their important role in the energy metabolism, that is like the carbohydrate, lipid and protein metabolism. They are take place in the presence of these glucocorticosteroid hormones. Okay. Then next is the zona reticularis layer. This is this known innermost portion of the adrenal cortex is known as the zona reticularis. And here zona fasciculata is the middle portion of the adrenal cortex, and outermost portion is known as the zona glomerulosa portion. Okay. So first of all, what is the importance of zona reticularis? The zona reticularis, this layer is responsible for the production of adrenal androgen and less amount production of the glucocorticosteroids. Okay. What happens when the ACTH will be enter into the adrenal cortex sites? That is, they are specially enter into the zona fasciculata and zona reticularis layer. Okay. This ACTH is not responsible for the production of the aldosterone. This ACTH is only responsible for the production of the glucocorticosteroid hormone as well as the adrenal androgen. Okay. What is how the ACTH will be released from the human body? First of all, when the stress and emotional condition will be produced in the human, at that time hypothalamus center is responsible for to release the CRH from the hypothalamus sites, and then after this CRH will be enter into the anterior portion of the pituitary gland, and at that time which release the ACTH. When the ACTH will be released from the anterior portion, what happen at that time? This ACTH, that is known as the adrenocortico hormones, and these adrenocortico hormones, they are migrated from the anterior portion of the pituitary gland towards the adrenal gland, that is adrenal cortex sites. They are enter into the zona fasciculata and zona reticularis layer. Okay, when they are enter into the zona fasciculata and reticularis layer, it contains the number of the cells will be present, and these ACTH, they are enter into the plasmic membrane of the cell. Okay, and in this plasmic cell of the cell, it contain adenyl cyclase enzyme will be present, and this ACTH is responsible for to stimulation of adenyl cyclase enzyme. When the adenyl cyclase enzyme will be stimulated, what happen at that time? They are responsible for the production of secondary metabolite like the cyclic adenine monophosphate, that is CAMP. When the CAMP will be produced, at that time the secondary metabolite is responsible for the stimulation of the protein kinase enzymes, and this protein kinase enzyme is responsible for the stimulation of the stimulation of dismolase enzyme. This dismolase enzyme, this is the dismolase enzyme, And when this dismolase enzyme will be stimulated by the presence of protein kinase, in shortly their dismolase enzyme will be stimulated in the presence of the ACTH. Okay. When the dismolase enzyme will be stimulated, what happen at that time here? This is the basic structure of the cholesterol. Okay, it contain how many number of the carbon atom? It contain the 27 carbon atom. Okay, this is the whole, or this is the starting point of the cholesterol. Okay, it contain 27 carbon atom. Here this numbering will be started from this point. This is the carbon number 1. This is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Then this 18 and 19 carbon is the angular methyl group. Okay. Then next is the 21, 20, 21, 22, 23, 24, 25, 26 and 27. These all the, that means cholesterol, it contain how many carbon atom? It contain 27 carbon atom. Okay. Then next point here, when the dismolase enzyme will be stimulated by the presence of ACTH, what happen at that time? What is the purpose of the dismolase enzyme? That is the enzymatic cleavage actions. What is enzymatic cleavage action? That means here in the cholesterol basic molecule, it contain, this is the what? This portion is known as the antenna portions. Okay, and this dismolase enzyme having the enzymatic cleavage action, and this dismolase enzyme, their destruction or cleavage of this antenna portion of the cholesterol. And then after, when this antenna portion will be removed, what happen at that time? This pregnenolone, this moiety will be produced. Okay, this is known as the pregnenolone. And this pregnenolone, these are responsible for the production of the various steroid hormones in the human body. First of all, in the human body, number of the steroid hormone will be synthesized. First of all, this is known as the mineral corticosteroid hormone, that is aldosterone. This is the one of the important steroid hormones. They are synthesized in the human body. Then next is the glucocorticosteroid hormone. This is another. Okay, they are produced in the human body. Then next is the what? Testosterone. This is the sex steroid hormone, like the testosterone and the estrogen, that is estradiol. These are the sex steroid hormone. They are also produced in the human body. And these all the, that is mineral corticosteroid hormone, hydrocortisone, that is glucocorticosteroid hormone, testosterone and estrogen. These all the hormones, they are steroid by the presence of what? This is the progesterone. This is the progesterone will be synthesized from the cholesterol. Okay, this progesterone is another steroidal hormone. And these all the hormones, they are produced in the human body in the different organ systems. First of all, this progesterone. Progesterone is synthesized in the human body. In which organ system? They are produced in the placenta sites. Okay, this is placenta site is a major organ system. They are produced the progesterone in the human body. Okay, then next is the mineral corticosteroid hormone, that is aldosterone, is synthesized in the human body. In which part? They are produced in the zona glomerulosa part of the adrenal gland, that is adrenal cortex sites. Then glucocorticosteroid hormone, they are synthesized in which part of in human body? They are produced in the adrenal cortex site in zona fasciculata as well as the zona reticularis layer. Okay, then next part is the sex steroid hormone. Okay, that is this sex steroid hormone is synthesized in the human body in which organ system? They are produced in the testes, that is testosterone is produced in the testis site, and then as well as the some amount, that is little amount, they are produced in the reticularis layer of the adrenal cortex sites. Okay, then next last point, estrogen. Estrogen is also synthesized in human body in which part? That is follicle layer in the female. Testosterone is produced in the male only, and in female, in case of the female, which produce the testosterone as well as the estrogen, because the testosterone is the intermediate pathway for the production of the estrogen. That means the in female is very clever, because female which produce the estrogen from the testosterone. Okay, and what is the difference between the estrogen and testosterone? In the testosterone, it contains only 19 carbon atom, but in estrogen case, that is in female sex hormone, it contains only 18 carbon atom will be present, so that female is very clever as compared to the male. This is the reason behind. Okay, then next point, important point is these are all the steroid hormone, they are synthesized in the human body, but also one of the important vitamin, that is vitamin D3. This is known as a 1,25 dihydroxy calciferol. These are the also synthesized in the human body, and this is the one of the steroid drug or steroid molecules. They are synthesized or produced in the human body. Okay, the next pathway for the production of the steroid hormone. Okay, when the cholesterol will be produced from the food material or some special cells which undergo the DNA synthesis reaction, then production of the cholesterol, and this cholesterol is produced in the form of the ester by the food and the some special cells. Then after, when the ACTH will be released from the pituitary gland, at that time they are enter into the adrenal cortex sites. In the adrenal cortex, in which portion, zona fasciculata and zona reticularis layer, it contain the number of the cells will be present, and this ACTH will be enter into the plasmic membrane of the cell in these two zona sites, and which undergo the adenyl cyclase stimulation. And when the adenyl cyclase enzyme will be stimulated, what happen at that time, which produce the secondary metabolite like the cyclic adenine monophosphate, and this cyclic adenine monophosphate is responsible for the stimulation of dismolase enzyme. When the dismolase enzyme will be stimulated, what happen at that time, this enzyme is responsible for two enzymatic cleavage of the cholesterol. That is, this portion is known as a antenna portion, and this antenna portion will be distracted by the presence of this dismolase enzyme, and then the production of the pregnenolone. Okay, then next important is when the pregnenolone will be produced, and these all the processes that take place in which part of the cell, that is, these all the processes that take place in the mitochondria of the cell. This all the process, that is a cholesterol dismolase enzyme by the presence and then production of the pregnenolone, and this production of the pregnenolone process is take place in the mitochondria of the cell, that is the zona fasciculata and zona reticularis layer. Okay, then after when the pregnenolone will be synthesized or produced, then after this pregnenolone will be migrated or transmit from this mitochondria of the cell into the cytosol cell. Okay, and when they are enter into the cytosol cells, at that time which undergo the various hydroxylase enzymes, they are interfere or react with this pregnenolone moiety, and which produce the number of the steroid hormone will be synthesized in the human beings, and all this process will be take place in various organ system, and this all various organ system which produce the various steroid enzymes. Okay, so first of all, to study about how the mineral corticosteroid hormone and glucocorticosteroid hormone will be synthesized in the human body. Okay, when the pregnenolone will be synthesized in the mitochondria of the cell, and then after this pregnenolone will be migrated toward the cytosol of the cell. When they are enter into the cytosol, what happen at that time, it contain 5-in-3-hydroxysteroid dehydrogenase enzyme as well as the 3-oxosteroid dehydrogenase enzyme. They are responsible for what is the main purpose of these two enzymes. First of all, when this cholesterol will be enter into the steroid pathway synthesis, at that time, first of all, here this portion, this is known as the antenna portions. If this antenna portion is not removed, what happen at that time, the rate of the production of all the steroid hormone is very slow, and at that time various problem will be created. So first of all, this antenna portion will be removed by these enzymes, dismolase enzyme. Then second point, the 5-in-3-hydroxysteroid dehydrogenase enzyme. What is the purpose of this enzyme? Here at the position 3rd, hydroxy group will be present, and this hydroxy group is a bulky group, and when this is the food of this molecule, that is their basement of this hydroxy moiety is present at the basement of this molecule. Okay, and when this molecule will be enter into the pathway of the steroid. What happened at that time? This bulky group is a migration rate of this moiety is very to decrease, so that first of all this bulky group is converted into the less bulky group. Okay, that means, and what is the importance of this 5-in-3-hydroxy steroid dehydrogenase enzyme? Their conversion of this hydroxy moiety into the carbonyl group. Okay, that means here this carbonyl group is a resonance stabilized moiety or resonance stabilized functional group as compared to this hydroxy group. Okay, this is the purpose of the 5-in-3-hydroxy steroid dehydrogenase enzyme. Okay, conversion of the hydroxy group into the carbonyl group. Okay, then next 3-oxosteroid dehydrogenase enzyme. What is the dehydrogenase? 4,5 isomerase. Okay, so here 3-oxosteroid dehydrogenase 3-oxosteroid 4,5 isomerase enzyme 3-oxosteroid 4,5 isomerase enzyme, and this enzyme is responsible for the shifting of this 5 to 6 double bond toward the at the position carbon 4 and 5. Okay, what is the importance of this isomerization? Because here when this unsaturated double bond when the shifted to the 4 and 5 position, at that time here which produce the conjugated diene systems. Okay, that means here this double bond is shifted at this position. Okay, that means here what happened at that time, this is a double, single and double, that is known as a conjugated diene system. That is, this conjugated diene system is the resonance stabilized. This is the importance of this shifting of this 5 to 6 double bond toward the 4 to 5 position. Okay, and when this double bond will be shifted at this position, at that time this all the moiety is a resonance stabilized. Okay, when this all the process will be take place, that is pregnenolone when they react with this 5-in-3-hydroxy steroid dehydrogenase enzyme, and second one is 3-oxosteroid 4,5 isomerase enzyme. At that time here progesterone moiety will be produced, and these all the processes that take place in which organ system? They are produced in the placenta site. Okay, in the organ and in the human beings. Okay, when the progesterone will be synthesized, then after another enzyme, that is 21 hydroxylase enzyme. What is the importance of this 21 hydroxylase enzyme? That is the substitution of hydroxy group at the position 21. Okay, this portion is the 21 portion, this is the 21 carbon atom. And what is the purpose of this 21 hydroxylase enzyme? Their substitution of the hydroxy group at the position 21 position, and then to produce the 21 hydroxy progesterone. Okay, then after when this 21 hydroxy progesterone will be synthesized, then after 11 beta hydroxylase enzyme. And what is the importance of this 11 beta hydroxylase enzyme? Because this 11 beta hydroxylase enzyme, they are substitution of hydroxy group at the beta position of the 11 carbon atom, and then to produce the corticosterone hormone. Okay, this is the corticosterone hormone. And then after 18 hydroxylase enzyme, they are responsible for to substitution of the hydroxy group at the 18 position of the carbon atom, and then to produce the aldosterone. This is the basic moiety of the aldosterone. What is the importance of the aldosterone enzyme in the human body? Okay, this all the mechanism will be studied or explanation will be later. Okay, then next pathway. This pathway that is pregnenolone to the production of progesterone, 21 hydroxyprogesterone, then after the corticosterone, and then finally production of aldosterone. This is the mineral corticosteroid pathway. Then next pathway for the production of the glucocorticosteroid hormone and the sex steroid hormone. In what is the difference between the mineral corticosteroid hormone pathway and the production of the sex steroid hormone on glucocorticosteroid pathway? So one of the difference is in this pathway for the glucocorticosteroid or sex steroid, there is the absence of the 17 alpha hydroxylase enzyme in case of the mineral corticosteroid. But this 17 alpha hydroxy These enzyme pathway, they are present in the glucocorticosteroid hormones and as well as the sex steroid hormone respectively. Okay. When the pregnenolone, they are enter into the cytosol sites, that is here the two tunnel will be present. This is the one tunnel, this is the another tunnel. This tunnel for the production of the what? Production of the glucocorticosteroid, and this tunnel for the production of the sex steroid hormone. Okay. When this pregnenolone will be enter into the glucocorticosteroid tunnel, at that time this tunnel presence of the 17 alpha hydroxylase enzyme, and this 17 alpha hydroxylase enzyme that is responsible for the substitution of the hydroxy group at the alpha position of the pregnenolone and then to produce the 17 alpha hydroxypregnenolone. Okay, what is the alpha position and beta position? That is known as the, that means this dotted line here written by the dotted line, that means this denote that this dotted line hydroxy group, they are not easily seen by the human eye, and this solid line, they are easily seen by the human. This is known as the beta portion, this is known as the alpha portion. Okay, that means this is the top portion of the molecule and this is the bottom portion of the molecule, and bottom surface of the molecule is always denoted by the dotted line, and top portion, that is the beta portion, is always denoted by the solid line. Okay, this all the chemistry is a explanation in the nomenclature and the steroid rules. Okay, this explanation will be later. Okay, when the pregnenolone will be enter into the glucocorticosteroid tunnel, what happened at that time? Here the presence of the 17 alpha hydroxylase enzyme, and this 17 alpha hydroxylase enzyme, they are responsible for the substitution of hydroxy group at the alpha position. Then after, when the 17 alpha hydroxylase and hydroxypregnenolone will be produced, then after they are again enter into the another tunnel, and this tunnel presence of these two enzymes, that is A means what? That is 5 in 3 hydroxysteroid dehydrogenase, and another is a 3 oxosteroid 4,5 isomerase enzyme, and this enzyme is responsible for, that is here hydroxy group will be converted into the carbonyl group. Then next 5 to 6 position of the double bond is shifted to the 4 to 5 positions. Okay, that is conjugated diene system will be formed, and then production of the 17 alpha hydroxy progesterone. Then after, when the production of the 17 alpha hydroxy progesterone, what happened? Then these 17 alpha hydroxy progesterone, they are again enter into the 21 hydroxylase enzyme, and that is this tunnel, and this in this tunnel presence of the 21 hydroxylase enzyme. What is the role of this 21 hydroxylase enzyme? They are responsible for the substitution of hydroxy group at this 21 position. This is the 21 position of the 70 alpha progesterone, and then to production of what? Then to production of the 21 hydroxy progesterone. 21, that is this 21 hydroxy progesterone is also known as the 11-deoxycortisol. Okay, this moiety is known as the 11-deoxycortisol. Okay, when the 17 alpha hydroxy progesterone is entered into the another tunnel, that in this tunnel presence of the 21 hydroxylase enzyme, and what is the importance of this enzyme? Substitution of the hydroxy group at 21 position, and then production of what? That is 11-deoxycortisol. When the 11-deoxycortisol will be synthesized, then they are entered into the another tunnel, and in this tunnel presence of 11-beta hydroxylase enzyme. What is the importance of this group enzyme? They are substituted, this is the 11 position, and they are substituted the hydroxy group at the beta position of this position, beta position, substitution of what? Hydroxy group, and they are denoted by the solid line, that is they are easily seen by the human, and then production of the hydrocortisone, that is known as the glucocorticosteroid hormone. What is the importance of this glucocorticosteroid hormone? They are explaining later. Okay, the next pathway, sex steroid pathway. What is the importance of the sex steroid pathway? So here, when the pregnenolone will be enter into the sex steroid tunnel, at that time the presence of this 17 alpha hydroxylase enzyme, and this 70 alpha hydroxylase enzyme having the two action here. One of the action is substitution of what? Substitution of the hydroxy group at this position. Okay, at this position. And then next another action is the 17 to 20 lyase action. That is the this portion. That is, this is the 17 carbon atom. This is 18 carbon atom. This is the 20 carbon atom. 17, 20 and 20 carbon atom. This portion is known as the 17 to 20 carbon atom. 17, 20 and 21. So first of all, what is the two action of this 17 alpha hydroxylase enzyme in the 6-steroid tunnel? The first action is substitution of the alpha hydroxylase group at the 17 position, and second action is lyase action. That is, the 17 to 20 carbon atom will be destructed or removed from the ring, and then only substitution of the what? Only substitution of the carbonyl group. This is the difference between of the 6-steroid pathway and the glucocorticosteroid pathway. When the pregnenolone will be enter into the glucocorticosteroid pathway, at that time the 17 alpha hydroxylase enzyme having the only one action, that is the substitution of the hydroxy group at the 17 alpha position. But when this pregnenolone will be enter into the 6-steroid pathway, at that time the 17 alpha hydroxylase enzyme having the two action. First action is substitution of the alpha hydroxy group, and suddenly they are produce the lyase actions on this position, and then this 17 to 20 carbon atom will be removed, and then substitution of the carbonyl group at the position 17, and then to produce the moiety is known as the dihydroepiandrosterone. What is the name of this moiety? Dihydroepiandrosterone. And when this dihydroepiandrosterone will be synthesized, at that time what happened? At that time this A enzyme, that is known as the 5-in-3-hydroxysteroid dehydrogenase enzyme, as well as the 3-oxosteroid 4,5 isomerase enzyme, that is what? This hydroxy group is converted into the carbonyl group, and then shifting this 5 to 6 double bond in toward the 4 to 5 position, and then to production of the androstenedione. Then after, when this androstenedione will be synthesized, here first of all in the production of the testosterone case, here this androstenedione is interfere with the, when they are enter into the testosterone tunnel, at that times they are interfere with the 17 beta hydroxysteroid dehydrogenase enzyme. 17 beta hydroxysteroid dehydrogenase enzyme is responsible for conversion of this carbonyl group into the hydroxy group. This, and then form moiety is known as testosterone. And then after this testosterone, when interfere with the 5-alpha reductase enzyme, they are responsible for the production of the 5-alpha dehydrotestosterone. Okay, this is the importance of this moiety. And okay, then next is when the androstenedione is undergo the aromatase reaction, then production of estrone, and estrone is undergo the estradiol dehydrogenation reaction, then production of the estradiol. Similar as testosterone, when the undergo the aromatase reaction, then also production of the estradiol, that is the production of the female sex steroid hormone, that is known as the estrogen. Okay, first of all, when the synthesis of the pregnenolone, it contain only 21 carbon atom. Basic moiety it contain only 27, that is cholesterol it contain 27 carbon atom, pregnenolone it contain 21 carbon atom, then aldosterone is also contain 21 carbon atom, hydrocortisone contain 21 carbon atom, testosterone it contain 19 carbon atom, and estrogen it contain only 18 carbon atom. This is the difference between the all the steroid hormones. Okay, if the 17 alpha hydroxylase enzyme deficiency occur in the human body, before to study, okay, what is the negative feedback mechanism of the steroid hormones? Okay, if the if the glucocorticosteroid hormone, that is hydrocortisone, then sex steroid hormone like testosterone and estrogen is synthesized in excess amount. What happen when this glucocorticoids, testosterone and estrogen, when excess amount synthesized, at that time excess amount of these all steroid hormone, that is glucocorticoid hormone and the sex steroid hormone, their negative feedback mechanism against the ACTH, that means excess amount of these all the hormone, they are responsible for inhibition of the stimulation of ACTH. If the ACTH stimulation will be inhibit, that is ACTH will be inhibit, that is there is no production of the ACTH, what happen at that time? There is no stimulation of dysphorinase enzyme indirectly, that is the ACTH. If the ACTH will be not synthesized or not stimulated, what happen at that time? ACTH is not enter into the adrenal cortex side, that is zona fasciculata side and zona reticularis layer. If they are not enter into the these two zona side, what happen at that time? There is no stimulation of cyclic adenyl cyclase enzyme. If the adenyl cyclase enzyme is not stimulated, what happen at that time? There is no production of secondary metabolite like cyclic AMP, that is known as the cyclic adenine monophosphate. If cyclic adenine monophosphate not activated or not produced, what happen at that time? There is no stimulation of protein kinase enzyme. If the protein kinase enzyme is not stimulated, what happen? Indirectly there is no stimulation of the dismolase enzyme. If the dismolase enzyme is not stimulated, what happen? There is no production of the pregnenolone, and at that time all the steroid hormone level will be balanced in the human being. Okay, this all the process is known as a negative feedback mechanism of steroid hormones. Okay, the next point is, if 17 alpha hydroxylase enzyme deficiency occur in the human body, what happen? This is very important point for you. If the 17 alpha hydroxylase enzyme production or deficiency occur of this enzyme in the human body, what happen? At that time there is no production of glucocorticosteroid hormone as well as the sex steroid hormone. Okay, but if the deficiency of 17 alpha hydroxylase enzyme will be occur, at that time more amount of the pregnenolone will be enter into the which tunnel of the production of aldosterone. Okay, if the aldosterone at that time, that is the production of the progesterone hormone highly amount, and then 21 hydroxyprogesterone is also highly amount. That means in shortly aldosterone hormone will be highly synthesized in the human body. This is the first point. If the 17 alpha hydroxylase enzyme deficiency occur in the human body, what happen at that time? First point is increase the production of the mineral corticosteroid hormone. What is the exact mechanism of the aldosterone hormone? The first of all, what is the action of the aldosterone? When the aldosterone will be synthesized in the zona glomerulosa site of adrenal cortex side, so at that times this aldosterone, they are first of all the steroid hormone, they are water insoluble, but they are soluble in the lipid. They are lipid soluble. When they are enter into the blood vessel, at that time in the blood contain the number of the serum protein will be present, and this mineral corticosteroid like that aldosterone, they are binds with the carrier protein, that is the globulin parts in the serum. When they are binds with this carrier protein, and what is the purpose of this carrier protein? Only the transportation of the steroid moiety. When they are binds with the carrier protein, then they are migrated or transported from the zona glomerulosa part to the nephron site. When they are entering into the nephron site, at that time this complex, that is the carrier protein and aldosterone complex, will be collapse, and only the aldosterone molecule will be enter into the nephron site. When they are enter into the nephron site in the kidney, what happen at that time? In this nephron cell, it contain the number of the receptor, aldosterone receptor will be present, and this aldosterone, they are binds with this receptor site. When they are binds with this receptor site, and then to formation of the complex, and this complex is known as a aldosterone response element, and this is also known as a steroid response element. And this steroid response element is responsible for migration of the aldosterone from the plasma cell into the nucleocytes. When they are entered into the nucleus, it contains the DNA sequence will be present, and at that time these aldosterone response element, they are specifically site of the DNA, they are binds specifically site of the DNA. Okay, when they are specifically site of the DNA site, when this hormones element will be bind, at that time which undergo transcription process, and when the transcription process will be produced, what happen at that time, which release the messenger RNA, that is known as a mRNA. When the messenger RNA will be released from this DNA sequence, then afterly this mRNA, they are interfere with the ribosome of the cell, and here translocation process will be take place. And when the translocation process will be take place, at that time the formation of the new cell, that is the new protein cell. And what is the role of this new protein cell? The role of the new protein cell is retention of the sodium as well as the proton level in the human body, as well as this at that same time what happened, expulsion of the proton, expulsion of the potassium ion. This is the role of the aldosterone. That means what, when the new protein cell will be synthesized, at that time this new protein cell is responsible for the retention of sodium as well as the proton and expulsion of the potassium ion. This is the exact role of the aldosterone. Okay, but if 17 alpha hydroxylase enzyme deficiency in occur in the human body, what happen at that time, more amount of the aldosterone will be synthesized. If the more amount of the aldosterone will be synthesized in the human being, what happen at that time, excess amount of potassium will be expelled from the human body, and excess amount of the sodium will be what, will be stored in the human body fluid, as well as the excess amount of also what is the exact mechanism action of aldosterone here? Retention of the sodium and expulsion of the potassium and proton. Okay, this is the clear point here. What is the role of the aldosterone? Expulsion of potassium and proton and retention of the sodium. Okay, if the aldosterone is highly synthesized in the human body by the absence of 17 alpha hydroxylase enzyme, what happen at that time, the sodium level in the human body will be increase highly amount and decrease the level of the potassium as well as the hydrogen, that is a proton. If the level of the proton, that is H plus ion, will be decreased in the body fluid, what happen at that time, the extracellular fluid will be decreased, that is a hypovolemia will be produced. Okay, and if the H plus ion concentration in the body fluid will be decreased, what happen at that time, the pH of the body fluid will be increased, that is they are converted into the alkalosis process, and this process is known as what, alkalosis process will be take place. And if the concentration of the potassium in the body fluid will be decreased, what happen at that time, which cause the hypokalemia. Okay, this problem will be created. If the alkalosis process will be take place, what happen at that time, there is no production of the renin enzyme. Okay, this is very important point. If the level of sodium will be increased in the human body, simultaneously level of potassium and proton will be decreased. If the H plus ion concentration in the human body will be decreased, at that time the body fluid pH of the blood will be increased, that is alkalosis. If the pH of the blood will be alkalosis, that is increase the pH of the blood, what happen, these all the alkalosis of the body fluid is responsible for decrease the production of the renin. Where the renin production will be take place in the human body, what is the exact location? Okay, first of all, this production of the renin is take place in the lungs. This is a very important point. First of all, angiotensinogen, this is the polypeptides, and this polypeptide is synthesized in liver system in the human body, and then after this angiotensinogen this polypeptide will be migrated into the renin, into the lungs, and in these lungs which undergo the production of the renin enzyme. Then afterly, this renin enzyme is responsible for the conversion of angiotensinogen polypeptide into the angiotensin first, and then angiotensinogen first is converted into the angiotensinogen second by the presence of ACE. What is the meaning of ACE? The meaning of the ACE is that is angiotensin converting enzyme, and this angiotensin converting enzyme is responsible for the conversion of angiotensinogen first to angiotensinogen second. Then after, aminopeptidase enzyme is responsible for conversion of angiotensinogen second to angiotensinogen third. Okay, what is the role of angiotensinogen second? The role of angiotensinogen second in the human body is to maintain the to maintain the blood pressure and blood volume. If the level of aldosterone will be increased, what happen at that time? There is no production of the renin. If the production will not take place, what happen at that time? There is no production of angiotensinogen second and third. If the angiotensinogen second and third is not produced in the human body, at that time decrease the body fluid. If the ACF will be decreased, what happen at that time? Decrease the blood volume, that is decrease the blood pressure. Okay, what happen if the 17 alpha hydroxylase enzyme is not deficiency occur in the human body? First point, increase the production of aldosterone. Second point, level of sodium will be increased, decrease the ACF, decrease the concentration of potassium, decrease the H plus ion concentration. If the H plus ion concentration will be decreased, which produce the alkalosis, and this alkalosis process is responsible for there is no production of the renin. If the renin not produced, at that time decrease the blood volume and blood pressure. This side effect will be produced, and which cause the cardiac arrhythmia, that is the death of the patient finally. If the cardiac arrhythmia will be produced, then heart attack will be produced, and then finally death of the patient. This is the if the 17 alpha hydroxylase enzyme will be deficiency occur in the human body. This is a very important point. Okay, then next point, if 21 hydroxylase enzyme also if the 17 alpha hydroxylase enzyme deficiency occur, then also sex steroid hormone level also decrease in the human body. This is the another third point. Testosterone and estrogen level is also decrease in the human body. Okay, then next, if the 21 hydroxylase enzyme and 11 beta hydroxylase enzyme deficiency occur in the human body, what happen at that time? Which cause adrenal congenital disease will be occur, that is congenital hyperplasia disease. What happen if the 21 hydroxylase and 11 beta hydroxylase deficiency occur in the human body? What happen? Which cause adrenal congenital hyperplasia disease will be occur. Okay, if first of all, if the 21 hydroxylase deficiency occur in the human body, if 21 hydroxylase deficiency occur in the human body, what happen at that time? There is no production of aldosterone. Okay, then next, what happen? Glucocorticosteroid hormone not produced. If the aldosterone and glucocorticosteroid hormone not produced, what happen at that time? Here sex steroid hormone level will be increased in the human body.